Hello friends, welcome to our YouTube channel. It's in continuation of my earlier video regarding getting roots of the cubic equation very quickly. So this is the last video for cubic equation, but in my previous video I've already explained how to get the roots of cubic equations, but in all cases this coefficient of first term is 1. But I have not explained a single example having coefficients other than 1, like here 3, 4, 10, 2, 15. So in this video I will explain you how to get the roots when first coefficient is not 1. So let's begin. Sorry. So here coefficient is not 1. So already I told you, if coefficient is not 1, then simply divide this complete equation by first coefficient. So divide 3, 3, 3, 3 and 3, and then it will become x cube plus 1 by 3 x square minus 4x minus 4 by 3 is equal to 0. And here this is the product and this is the sum. In case where these coefficients are in fractions, so in this case it's better to start from sum, not from product. We will start from sum and accordingly we will verify the product. Till now what we have been doing, we have been starting by taking 3 obvious factors from product side, and then we were verifying sum of all those factors as equivalent to this second coefficient. But as these coefficients are in fraction, we will start from sum and then we will reverse verify it for the product. So let's start. So here the sum is 1 by 3. So what can be? Sum should be 1 by 3. As cubic equation will have 3 roots, so other 2 roots or other 2 factors should get cancelled out. So let it be plus minus a. Then what should be the value of a? See here 4 is there. 4 is a perfect square. So definitely in place of a we can have 1 by 3 plus 2 and minus 2. This will be cancelled out and resultant will be 1 by 3. But we have to verify. Sum is okay. Now we have to verify the product. Clearly we can see 1 by 3 into 2 into minus 2 will give minus 4 by 3. So this is perfect. So these are the three factors, and roots directly roots can be written, just change the sign, minus 1 by 3 minus 2 and plus 2. These are the roots. And if we want to write in factor form, then simply x plus 1 by 3, x plus 2 and x minus 2 is equal to 0. But as we have divided this initial equation by 3, in order to make up for that we have to multiply. Finally, in final step we have to multiply by 4, multiplied by 3. We have to multiply by 3. Now it will become 3x plus 1, x plus 2 and x minus 2 is equal to 0. So this is the factor form. This whole polynomial, this complete polynomial is broken down into 3 factors. So now let's start with another one. 4 is the first coefficient, so just divide. It comes out x cube minus 1 by 4 x square minus 9x plus 9 by 4 is equal to 0. So this is the product and this is the sum. As this last term and second term are in fractions, we will start with sum. So minus 4 plus minus something, and what the value should be of this something. Just see, this is 9. 9 is a perfect square, as here 4 was a perfect square. Here 9 is a perfect square. So here also we can have plus minus 3. So minus 4 plus 3 minus 3, this will cancel out, and 1 minus 1 by 4 will be there. So sum is satisfied. Now let's check for product. Minus 1 by 4 into 3 into minus 3. Two negatives are there, so two negatives will make positive. Satisfied. So roots will be, change the sign, 1 by 4 minus 3 and plus 3. So these are the roots. And in terms of factors, we can write x minus 1 by 4, x plus 3, x minus 3 is equal to 0. Just multiply it by 4. Why? Because initially we have divided by 4. So in order to make up for that, we have to multiply it by 4. So it will become 4x minus 1. And these two factors will remain as it is. So it's done. Now let's try another one. 2 is the first coefficient. It means we have to divide the complete equation by 2. We will get x cube plus half x square minus 13 by 2 x plus 6 by 2 is equal to 0. I am not reducing it to the simplest form like 3. I am not reducing it by to 3. I am keeping it as it is because it will help me in finding the roots quickly. Here half is there and here 6 by 2 is there. Here as a sum, final is half. So shall I take this? Shall I use this method or not? I cannot use this method because plus minus a, this 6 cannot be converted into plus minus a because 6 is not a perfect square. 6 is not a perfect square, unlike 9 and 4. So in order to have here, I should have half like 6. It's easy to get factors from product side. Half into 3 into 2. So if we take all positive, then product will be positive. But the sum will not be half because if we add all this, it's not going to give us half. So we have to modify signs. So what can be the sign? Positive half is there. So sum of all this should be positive. How we can have its sum as positive? We can make 3 as positive, and this 2.5. If we subtract 2.5 from 3, it will give us half. It means we have to make this half negative and 2 negative. This negative and this negative. So what it will look like? Minus half into 3 into minus 2. So sum is minus half minus 2 plus 3. So this 2.5, negative 2.5, and this positive 3. Obviously, it will give half. So clearly, this satisfied, and so roots can be written as, change the sign, half minus 3 and plus 2. These are the roots, and factors we can write x minus half, x plus 3, and x minus 2 is equal to 0. As we have divided by 2, we have to multiply by 2, and now the factors will become 2x minus 1, x plus 3, and x minus 2 is equal to 0. So done. Now let's try the next one. Just divide by 15. So it comes like x cube minus 31 by 15x square plus 0x plus 4 by 15 is equal to 0. So this is the product. So let's start from sum. Just simplify the sum. Sum can be written as this is minus 30 minus 1 by 15. So it's minus 2 minus 1 by 15, and this minus 2 minus 1 by 5 cross 3. So it's a very old method. when when Egyptians when Egyptians didn't know how to multiply or how to divide. So at that time, these fractions, Egyptians were used to write fractions as single fractions as sum or difference of two fractions, because at that time they didn't know the multiplication. So, so that means nowadays also that method is used. See, this is a single fraction minus 1 by 15, and think like Egyptians. If they don't know multiplication, they will try to write this single fraction as difference of two fractions or sum of two fractions. So how it can be written? See, this minus 2 will be like that only, and this minus 1 by 15, this difference of these two factors is generally taken. Yes. So how we can write? We can write like that. This minus 2 by 5 plus 1 by 3. This 1 by 15 or 1 by 5 cross 3 can be written as sum of two fractions. So just cross check. 3 cross 2 minus 6, and 5 cross 1 plus 5 minus 6 and plus 5 minus 1 by 15. So correct. So this sum is okay. And now let's check whether product is satisfied or not. So minus 2 into minus 2 by 5 into 1 by 3. So this is two negatives. Two negatives will make positive. So 4 by 15. Yes, it's coming 4 by 15. So our choice is perfect. So these are different factors. So roots can be 2, 2 by 5 and minus 1 by 3, and factors, this equation can be written in the form of factors like x minus 2, x minus 2 by 5 and x plus 1 by 3. Now we have to multiply this equation by 15 because we have divided by 15. So multiply by 15. So 15 out of 15 is like 5 cross 3, and this 5 comes here and 3 goes here.